on 8051 programming in embedded C. So learning outcomes will be, you'll be able to write a Keil program using Keil compiler. Program will be dealing with the bit addressable IO programming, and you'll be able to compare the assembly language programming approach with the C programming approach. So this is the problem statement we will take. A door sensor is connected to P1.1. So two pins of the port pins of the microcontroller are used. So and buzzer is connected to P1.7. So write a program so that when door sensor gives you the input, it should when it opens, it should sound a buzzer. Sound a buzzer means you should generate a square wave and onto the port pin where the buzzer is connected. Now we'll go to the programming part. So now Keil IDE, when you open, so let us create a project. So let us create project onto C drive. So in this for project, I create a project with the name door sensor. Select the microcontroller. We don't want any startup code for this. So here you can start typing the code. So we'll be writing C program for accomplishing this task. Include. We include a file reg51.h. Now two port pins we are using, so define those port pin names. Sensor is connected to port 1.1 and buzzer is connected to port 1.7. Now for generating a square wave we will require a delay. So declare the delay function. Unsigned integer is the data type, which will be the number of milliseconds delay you want to generate. Now we write main function. Now initially I switch off buzzer. And assume sensor is giving you output as 1. Now continuously you have to check for the sensor input. So I write infinite loop while 1. So what you test is if sensor input is 0, so you have to turn on the buzzer. So buzzer means you have to generate a square wave. So what I make is buzzer is equal to 1. Then I call delay, let us say 200 millisecond delay, and again I make buzzer is equal to 0. Again I call that delay. Now you should declare that delay function. I take two variables, unsigned int ij, and then I run a for loop for the parameter which is passed. So, and in this for loop I just execute a program which takes 1 millisecond for its execution. Now whatever code is written, you save this code, give some name, this is a C code, so save it with the extension .c. Add this file to the project. Build the target. So your code is compiled successfully. Now you want to check the output for this particular code. So you can run this particular code in the debug mode, and what you can do is you can check the contents of the port. So P1.1 is connected. So when that pin is open, so you'll find that this particular port pin is continuously going high and low. It indicates that buzzer will turn on. So this is how you can write a program which will create a hex file. For creating hex file, you can click on the options for the target, and here you create a hex file. As well, if you want to generate assembly language code for the C code which is written, go to the listing and there you enable assembly language code. So click on OK. Again build the target. Now you can check the folder in which that C code was created. So you will find hex file. As well, in the C code you can find a hex file created, as well as this assembly language file. So you can open this, and here you'll find the equivalent assembly language code which is generated by the assembler. These are the references used for this presentation. Thank you.